Hello everyone. Now, we will talk about graphs that are used in kinematics. As we know, kinematics is a branch that deals with the motion of objects such as distance, time, velocity, and speed. So, we use different kinds of graphs to explain these motions. Now, the first easiest graph from the kinematics is the distance and time graph. One unique property about distance-time graph is that it is always non-decreasing and positive graph. As we know that, as time always progresses ahead, the distance covered by a vehicle is either zero, that is if the vehicle is stationary, or positive if it moves in any direction. We also know that distance and time both are scalar quantities. So the graph doesn't really need a direction to specify. We can just plot a graph, and then we can get simple curve or a straight line depending on the motion of the object. The gradient of the distance-time graph at any point is equivalent to the rate of change of distance, that is speed. The definition of the word gradient in scientific language is basically the change in some value. In this case of a distance-time graph, as time progresses, the velocity or the distance traveled by any object changes or remains the same depending on the motion of the object. So, the gradient is basically the change in distance-time graph or change in the speed with respect to time. Now, the diagram here shows the change in the gradient or change in the distance-time graph depending on the motion of the object. Now, first square right at the bottom, right beside the origin, we can observe an increasing gradient. This increasing gradient shows that object has traveled some distance as the time passes. After that, there is a horizontal line parallel to the time axis in which the object is not covering any distance, it is only progressing in the time direction. So that means, in that case, the vehicle is stationary. Horizontal line indicates the gradient is zero as there is no change in distance, the speed is zero again, because there is no change in distance. In the third section, we can see the constant gradient, which means the constant speed in which the distance traveled by a vehicle with respect to time is constant. There is no change in acceleration, or the vehicle is not decelerating in that space. In fourth section, we can see the constant speed similar to the third section. But here we have less slope to the line, which means slower speed because the time taken by a vehicle to cover same distance is more. So, distance traveled in unit time is less. So, we will get almost low slope line, which means the vehicle is at constant speed but lower than the previous one. In the second last section of the graph we get a decreasing gradient, which means the speed is decreasing as the time passes, and at the end, graph is exactly coinciding the x-axis or the time axis. Then we can again say that the object or vehicle is back in a stationary position.